Okay, to start with, this is a little bit like the absolute values you did yesterday, except I've added a twist that would be a typical thing you do on a test and say, instead of just solve this, find its x-intercepts. And I'm going to pause for a second while you give that a try. Mr. BD, could you tell me, what did you start with? Since I said x-intercept, what did you say?
I made y 0.
Excellent. You made y equal to 0. And then what would you do after that?
At 5.
Excellent. 5 equals negative 3x plus 4. All right. Let's take it from there, JW. Take it from there, JB. Interesting. How about if I ask you this way? What are the two equations that I could solve at this point? And I want you to note that that's the same exact thing as is on the board without the absolute values. That's the easy way to start. It's just take the absolute values out, and that's your first equation. Now, say that other thing you were saying now. Positive 5 over 3. All right, awesome. And now, okay, IB, can you tell me what to do next? Yes. All right. And I'm going to do that by...
Factor 4.
Good. But I really don't like to have to deal with fractions. Can you figure out a way, AF, could you figure out a way to get this so it doesn't have fractions in it anymore? All right. And both sides, yeah, I guess you're right. If I just go like this, though, it's a common mistake. Because kids will say it's 3x plus 4. What am I missing then? Yeah, exactly. So 3x plus 12. And I know some of you are like, I never did that. You didn't have to do it this way. This is just a way to do it where I don't have to deal with a fraction anymore. And now I can solve it without fractions. No subtracting fractions involved at all. Okay, so now I'm going to subtract 12 from both sides. 3x equals negative 17. And then divide by divide by 3. Sorry. And then there's my answer. Negative 17 thirds. Wrong. Anybody catch that it wasn't actually correct? Do you remember that deal? What is that deal again? Like, if yes? Oh, so every time you get an answer that's negative? Oh, okay. So what do you mean about the negative number thing?
So when it said, like,
Right there, you could have known what's bad about that? Absolute values can't equal negatives. If you just look at that right there, you'd say, okay, I know that this one's going to not have answers that are possible. You can't make absolute values be negatives. But it's not okay to, at this moment, just stop the problem and say no solution. I wouldn't give you credit. Because there are solutions, they're just, what are they called again? Extraneous. Okay. Now, could there be an answer that actually works here? Is it even possible that one of my answers could work? No. In this case, it is not possible. Because no matter what number I put in here, you're never going to get an absolute value to come out negative. So I know both the answers that I would get would not be possible. What does that mean about its x-intercepts? There isn't any. Could you draw a V shape? Since this is just a big V shape, could you draw a V shape that doesn't touch the x? Yeah, you could. There's a lot of ways to do it. It could be upside down like this one. It's an upside down V. And if it's upside down and moved to the left 4 and down 5, then it's an upside D that kind of looks like that. It doesn't have an x-intercept. All right. Could I have asked you to find its y-intercept? Yeah, I could have. If I'd asked you for the y-intercept, you would have said what? X equals 0. And if x equals 0, instead of y equaling 0, we change the x to equal 0. Could we possibly come up with an answer for that? Yeah, actually, we could. Okay. All right. Good enough. Good talk. What was the theme from yesterday? Two things. Absolute values have a process that involves splitting into two parts, but a lot of times you get answers that are no solution. Make sense? So watch out for that. All right. So I am going to pause for a second while we pull up the notes for today. Okay. So this one has an absolute value and a quadratic. What if it just had a quadratic? Do you remember how to solve quadratics? You always set them equal to what? 0. Once you got them set equal to 0, then if you can factor it, you should. And I could solve this thing, but just to clarify, solving it by setting it equal to 0 gets me just the two dots that are like here and here. What does it really look like? It's a parabola. And if it's a parabola that's got absolute values around the outside, oh my gosh, there's so much math in this. You got to know that it's a parabola. You got to know how to graph a parabola. You got to know how to factor. You got to know that when you do factor, you're actually getting the y-intercepts because the x-intercepts because you're setting y equal to 0. And so you're really just getting these two spots here. And then you got to know the concept of absolute value around the outside, which means which part changes, the y's that were negative or the x's that were negative. When you absolute value the outside like this, is it the y values that change? Yeah, it is. So it's the y values that are underneath like this. They got to flip up. Do you get how many different pieces there were to that? You had to know what parabola was. You had to know how to factor. The factoring would tell you these two roots. And then you got to know how to do absolute values, which we had last chapter. Do you think we could actually test you on it again? Yes. Can't just like let stuff go and say, I already did. That was last chapter. We don't have to know that anymore. All right. I want you to finish this up and actually do it accurately with the factoring right, which would tell you exactly where these roots are, etc. So we're going to look very similar to that, but know what the actual numbers are. I'm going to pause for a second while you give that one a try. Okay. That can be factored. EB. What'd you get?
X plus 2 and x minus 3.
All right. And then if I take the absolute value, that's going to tell me, oh, wait a minute, where are my roots? I have -2 and +3, and then it's a U shape like this. And then, oh, now is the moment where I have to do the absolute value. Raise your hand if you had that W, basically. Okay, good. All right. So let's move on to more difficult things. This one is a quadratic without the absolute value. And if I want to find its x-intercept, I'd set y equal to 0, right? And then you'd have to solve a quadratic. There's two ways you can do that. You can multiply it all the way out and use the quadratic formula. Are you fluent with quadratic formula? X equals -b plus or minus square root b squared minus 4ac all over 2a. Hopefully you got that one down. If that doesn't work, you could factor it, but look at this one. Does it look like it's all factored nicely for you? Just to clarify, this is not in factored form. It's got some factors, but it's not just like two things multiplied equaling 0. So that is not factored. What it is set up really well for is to tell me, do you remember this? It's been moved over to the left, no, to the right 5 and down 13. It's really good for finding its what? What is that spot? Vertex. Okay. So there's a dot there. It's upside down parabola, so it goes like this. And I know from looking at this, it does for sure have x-intercepts, which is where y would equal 0. Okay. So if I wanted to find those spots, now I have two choices. I can multiply it all out, which is going to be a pain in the neck. Or I can solve it from here. It's just a simple equation. Act like we're not doing a graph. And if you just had to solve this, you remember you start with the order of operations and you go completely opposite of normal. So start by adding something. What are we going to add? Or subtract. I feel like I lost some people at some point. I need you back with me. X minus 5. There. Are you with me so far? Is this making sense? Okay. So we did our add subtract. Now we have to do a multiply divide thing. Now I'm just following my order of operations. I'm done with my add subtracts. Any multiply or divide I could do? Yeah, multiply by what? -1. Could you divide it by -1? Sure, but it's easier to multiply by a number than divide by it. That becomes positive 13 equals positive x minus 5 squared. There, I've done my add subtract. I've done my multiply divide. Mr. B, what do you do to finish this thing?
Square root.
Square root. Square root. And I have square root of 13, which isn't a very nice number, so I leave it as a square root of 13. And do you remember there's a tricky part here? What do I do here? It's not x minus 5. There you go. And then we have to do it twice. Once without the absolute values. And once that's very similar, except an opposite of. And you actually could have put the opposite on either side. But I personally like to keep the solo number, make it positive, and make it negative. What I'm trying to say there is you could have made the negative sign here, not here. You could have made it on this side. But I think it's more likely you'd mess it up if you did that. Okay, so now to finish this off, I'm going to try to be smart and do this all in one step. I'm going to be adding 5 to both sides. So I'm going to have a positive 5, and I'm going to have a plus and minus the square root of 13. Did I skip too many steps in there? Are you okay with that? So you might be saying, okay, in the context of the graph, Mr. Server, what the heck does that mean? Well, it's a decimal. It's just not a nice exact spot on the graph that's like 7. It's 5 plus the square root of 13 is one of your roots. And 5 minus the square root of 13 is your other root. All right. So completing the square, another important skill for today. All right, so I want to take a second and say that's called a perfect square because that is identical, okay? If I multiply it all the way out, I'd have x squared plus 6x plus 9. This one is very hard to look at and say, oh, that's a perfect square trinomial. It's difficult to look at that and say ahead of time, oh, that's going to turn out to be a perfect square. But once you get it all factored, x plus 3 and x plus 3, and then realize, oh, that's the same thing. Then hopefully you'd be able to recognize if you have a perfect square or not. Okay? Let's look at this one. Is this one a perfect square? So the question becomes, can you factor it into two identical things? Can you or not? No, you cannot. It isn't x plus 1 and x plus 1. That doesn't work because it doesn't give me a middle term of 8x, right? Okay, so this is not a perfect square. But we can do what's called complete the square. And that's one of the things I need to teach you for today. All right? So what would it be nice if that number was right there? Anybody tell what number would work really well if it was right there? Yes, VV. What? 16. If I put a 16 right here, let's see if she's right. Can I now factor it into two perfect things? that will make it work? Yeah, x plus 4 and x plus 4. Do you know how we could have predicted what number would have worked nice? I know you might have just kind of done it in your head. Yes? Yep. Exactly. I'd call that half and squared. Take half of this and square it. All right. So now you might be saying, okay, fine, Mr. Server, 16 would have been nice, but it's not 16, it's 1. How do we make it be 16? Would you agree that I can add anything I want as long as I do it to both sides of the equation? So I could add 15 to this side as long as I add 15 to that side. You get what I'm doing there? Now this part, I think you're gonna be okay with this, but do you get that I could also add 15 and simultaneously subtract 15 instead of adding 15 to both sides? Do you get that that's legal to do? You might not understand why I'd want to do it yet, but do you get I can add 15 and then immediately subtract 15? Okay, here's why you'd want to do that. Because now this part comes out to a perfect square and can be factored. And what does that look like again? We just did it a second ago. X plus 4 quantity squared. And then the end of it is just minus 15. So there's my answer. What just happened? We just rewrote this. It actually has the same value. It's in vertex form, exactly. It took something that was in standard form, a standard quadratic, and we wrote it in vertex form. And so I often call this complete the square for vertex, because that's why you do it. It's because then you know the vertex of the parabola. Why is the vertex special? Because if you know the vertex, do you get it's the answer to so many different questions? If I was going to ask you about this, if I asked you for the minimum, I'd need to know the vertex. If I was going to ask you for when does this thing stop decreasing, I'd need to know the vertex. Do you get what I'm saying? If I had to know how far over has my parabola been shifted, I would need to know the vertex. So the vertex is a very powerful point to have. So you can find the vertex by what's called completing the square. The last time I used this word, I actually heard it from a kid. And he told me, yeah, I was practicing for my PSAT because I knew I had a chance at National Merit Scholar. And your class, I do this class on it. And your class made me take some practice tests. And I realized I'd forgotten how to complete the square. And so I brushed up on it, and then he said, and it was actually there. It was on the PSAT that I took, and I was so glad I brushed up on it, because then I just got that question right, and he became a National Merit Scholar. So it can come down to just one thing like this. It was the one thing that was going to hold you back. And anyway. So yeah, you could actually see this on a big important test in your life. Completing the square. All right. So I want to give you one that's not quite as complicated as that one. See if you have learned completing the square yet. X squared plus 6x plus, for right now, I'm just going to keep it simple and say 1, because I know you're going to look at that and go, I can't factor that. Does it have to be a 1 right there? No. In fact, I think you can handle this one. Let me change this to a 5. Oh, wait, that can be factored. But it can't be factored to a perfect square. So I'm going to make it, how about we use a 2? Just anything so you don't think it always has to be at 1 there. Okay, write that one down. Now do that little complete the square process if you understood it. Step 1 was figure out half and square. Then remember that if you add it, you also have to subtract it. Then try to have an answer that looks like this when you're all done. I'm not saying this is the right answer. It should look like that. Vertex form. Pause for a second. Let me give that a try. Okay, kids are feeling confident from my question. Do you feel confident? All right, so half and square. Half of 6 is what? 3. And then 3 squared is 9. And so wouldn't it be nice if this was a 9? But it's not a 9. So what should I add to it? So it should be a 9. 7. If I add 7 and then subtract 7. Does that work? Yeah, that works. Is there another way to do it? There is another way to do it. But see if you get the same answer at the end. Okay, so now I have got x squared plus 6x plus 9 minus 7. I just put those together. And I always do it by adding something and then subtracting something at the same time. Now this part is my perfect square. And so when it's all done, I want something to look like that, right? So x plus 3 quantity squared is what this factors to. And then there's a minus 7. Raise your hand if you add that. Awesome. Now from that, we can graph this thing so much easier. I know where the vertex is. The vertex is at 3 to the left and down 7. Dot right there, and it's a right side up U. And for things like increasing, decreasing, range, you know how you need to know the low spot to get the range? Which of these two numbers, the -3 or the -7, which of them tells me the range? The -7 is correct. Okay. All right. Then the domain, well, domain's all real, so that's pretty easy because it goes forever this way and forever that way. But increasing and decreasing needs the x number. A quick reminder, it decreases from -infinity until -3, for example. That's decreasing interval. All right, that's what your homework's like. Let's go look at it. Everybody find, actually wait, before we get there, I should talk about the quadratic formula. I just super briefly touched it. I'm going to touch it in one more way and to remind you of a couple little things that are built into it. Do you remember this from last year? It's called the discriminant. Do you get that if that part is 0, that's kind of special? I'll remind you what that means. If you have a 0 there, then do you get the plus and minus 0 will do the exact same thing? If you add 0 or subtract 0, it's like that isn't even there. So that 0, this being 0, means all of this just cancels. If that's ever 0, that all cancels. What's cool about that is you're left with negative b over 2a, and I reminded you earlier, does anybody remember this? It's the formula for the vertex. That's the x of the vertex. If you didn't know that, you better take notes on that, right? Vertex. That's the formula for finding the vertex. Because think about it. That means you've only got one x-intercept. How would a parabola only have one x-intercept? Think about it. A parabola looks like this. How would a parabola only have one x-intercept? If it's touching right at its vertex. See? All right. And that was if this thing under the root, which is called the discriminant, if that was also like, I don't remember that from last year, the discriminant, if the discriminant, which is b squared minus 4ac, if the discriminant is positive, you get two answers. 12-minute warning. If the discriminant is less than 0, as in negative, if it's negative, what would happen if there was a negative number underneath there? We'd have no real solutions. And if that discriminant is equal to 0, that's that special case where all of this will cancel and we get the vertex, which of course is only one solution. All right, I know that went kind of fast, but that's something you did for a whole week and a half last year, and I'm supposed to be able to just remind you quick, and it's supposed to be okay. So let's just take a second and go through those possibilities one more time. Let's say you get a negative number under here. That's the easiest case. If I get like negative 23 underneath there, do you get there's no answers? And what does that mean about this graph? It doesn't have any roots or zeros. What if I get a normal number like 24? Then it's got normal answers. There's got two normal roots. because you're going to be doing plus 24 and you're going to be doing minus 24, and you get 2 roots. It's got 2 x-intercepts. And last possibility is if this thing is 0, if the whole thing just equals 0, it's kind of nice, because all that cancels, and you have just one answer, and it's the what? The vertex. All right. There. There's your new stuff for today. So now, take a look at the homework, which starts right here. Does that look like a parabola that's been shifted up to? I hope that rings a bell. Do you remember me saying that your best friend in graphing is an XY chart? Because if you forget, like, I don't know what this looks like, you can always make a few dots, connect the dots. 0, put in 0, you'd get 2, and you'd be like, oh, it starts here, and oh yeah, that's right, it's a parabola, it goes like this. Okay, so once I got my little sketch, it's pretty easy to answer these questions. What's the x-intercept of it? Doesn't have any. What's the y-intercept? Oh, it's that spot. Y-intercept, I like it when you put a point, but you could have said y equals. If I'm going to put a point, the x-intercept is where, or sorry, the y-intercept is where x is 0. So 0, 2, or you could have said y equals 2. The domain of this thing is all reals. The range of this thing, how low to how high. Anyway, I think you remember how to do this. I hope you remember how to do this. I want you to do the 2 that are on the board here. Hint, one of my favorite sayings, if you can factor it, you should, comes in. Because if you could factor this thing, then you're finding the roots. See what I mean? All right. Now, let's go to this one. We haven't had to complete the square yet. Now, I spent some time today to do complete the square. That's going to come up more in future lessons. But it was sort of just meant to be like a quick touch on complete the square. I thought it would be good to tell you, you could do complete the square even on this. But the fact that it has a number in front makes it really tricky, so I wouldn't even bother trying that one. But what if you needed the vertex? What was that formula again? The little short little formula for vertex? There you go. And do you get why it'd be handy to have the vertex? Because like everything's based on the vertex. Once you know the vertex is like here and it's an upside down parabola, you pretty much can answer the x-intercept, the y-intercept, domain, range, increasing, decreasing. Not all of those, but a lot of those come from the vertex. Okay, so you don't have to do complete the square. That guy, negative b, negative 4, over 2a, 2 times negative 3, makes negative 6. Negative 4 over negative 6 is positive 2/3. X equals 2/3 is the x of the vertex. So over 2/3, comma, and then, yeah, it's a bit of a pain, but you'd have to stick that in if you want to know the y value. When would you ever need the y value? For the range. So to figure out the rest of this vertex, there's my x. I'd stick it in here, and I could find the range that way. There's other ways to do it. I'm just trying to remind you of all these powerful formulas you used to know. You used negative b over 2a 4 or 5 times last year. I've forgotten it. Okay. This one, I am going to let us skip this one this time. This one is a lot like the tennis ball lab. You should definitely do that one. And so only that one. So crossing off this one. It does say challenger, and that's also a sign that you don't have to do that. If you've got the time and the interest, feel free to challenge yourself. 6 and 7 give the values m. All right. This is really important. I saw an ACT question. It was just like number 7. And then we're going to stop and say that this is the whole rest, and any problems after this you can skip. Okay, so just do 6 and 7 and then stop. I saw an ACT question that was just like number 7. Do you remember that whole 1 solution, 2 solutions, no solutions thing? Isn't that based on the thing underneath the square root? All right, I know I've lost a lot of you, but if I were you, I'd write down this. b squared minus 4ac. Because that's the thing that is called the discriminant, where if it comes out positive, you get two solutions. Negative, there aren't any solutions. And if it comes out 0, there's only one solution, and it's the vertex. So you'd need this little guy to do number 7. Okay, that's all I got for you for today.